Hello friends, my name is Shamli Tiwari and I am welcoming you to in my new video. In this video, we are going to learn about the basic concepts of the physics, that is rest and motion. First of all, what is meant by rest and motion? In this chapter, we will see the difference between the rest and motion. Here if you will see in the figure, you will understand that the things which are not moving, which will be constant at a point, is called as rest. And what is mean by motion? When your object is in moving from one place to another place, just like man is throwing the ball, man is walking, also ball is going from one place to another place, so that time ball is in motion. Now bird is flying, birds are flying are also the examples of motion. Here honeybee is moving from one place to another place, that is also comes under the motion. But home, house is not moving from one place to another place, it will be stable at one position, so that is called as rest. Tree which is not movable, so that we are calling it as a rest. And the electric pole is also one of the example of rest. Let us see about rest and motion in details in this video. So, our introduction topic is rest and motion. Here, you can see the Tom and Jerry are playing, and in one picture, they are sitting quietly. So, in the picture where they are sitting quietly is called as rest, right? When object is not moving, Tom and Jerry are not moving in this case, right? So, with respect to what? When we are saying that object is not moving with respect to time and surrounding, means for some time it is constant, and also with surrounding means about its position, different positions, it is not moving from the point, so that position we are calling it as a rest. That position of the object is called is at a rest, when object is not moving with respect to time and surrounding. Now here, Tom is behind the Jerry. Jerry is laughing, right? So, motion, when object is moving with respect to time and surrounding, is called as motion. Motion and motion and rest are very important concepts while seeing in the physics, because this motion and rest are based on the observer's frame of reference. It does not depend on the position of the object actually. How we are saying like that? Let us see the example in the next case. In the next slide, we are going to learn about the frame of reference. What is mean by frame of reference? Frame of reference is the background from which the observations are to be made, right? For example, here we have drawn one tree. Tree is in the state of rest according to the person who is standing here nearby the tree, right? But if we will consider one's earth, right, and from this moon, this is the moon, suppose if person is there on the moon, or he is the person who is observing earth from outside from the earth, and here on this earth somewhere tree is there, this tree whatever we are talking about, this tree is there, according to this person who is observing that tree from outside of the earth, that is called as what? According to him, it is in the state of motion, because earth is moving with respect to earth is moving with respect to uh, earth is moving with respect to this person, right? Because earth is moving. Now if earth is moving, tree will also move, right? So therefore, according to this person, the object is in the tree is in the state of motion. But according to this person who is on the earth, again the tree is also on the earth, according to that person the tree is in the state of rest, right? So rest and motion both are the combined property of an object which depends upon the observer. Observer is important in this case. Are you getting everyone? Yes. So let us see the next one. In this example, see, rest and motion are, as we are saying, it is based on the observer's frame of reference, means according to whom we are saying the object is in state or object is in the state motion, according to whom we are saying, we need to consider this, right? Here the rest and motion are relative. This relative word shows that object is based on the observer's frame of reference, right? Now according to us, the motion, this school bus is standing in front of the school, right? But according to this person, this school bus is moving, because inside the students, who are students inside the bus, they are feeling that they are sitting simply, they are not moving from one place to another place. Therefore, the person who is inside the train, inside the bus, according to them, they are in the state of rest. But the person who is observing all of the students from outside the bus, right, according to them, they all are in the state of motion. The same situation is there, that are 4 5 members are there inside the bus. According to the students who are already inside the school bus, according to them, they are in the state of rest. But the person who is observing them from the outside, according to them, they are in the state of motion. See here, few statements I have made based on this only, very important statements. Rest and motion are relative. Rest and motion are relative. Yes, motion is the combined property of an object and an observer. It does not depend only on the object, also, it does not depend only on the observer. It is combined property of an object and the observer. Now, there is no meaning for the rest and motion without observer. If observer is not there, how we can say the object is in the state of rest or object is moving, right? Therefore, there is no meaning for the rest and the motion without observer. Observer is very important in that case. Now, nothing is in absolute rest or in the absolute motion. Based on different examples we can give here, bus example and students example we have considered. Even we can also one example we have given, that earth and the tree. The person who is observing that tree on the earth surface, they are in the state of rest, and the person who is observing outside the earth, they are, for them, the tree is in the state of motion. Like this, number of examples we can give. For example, we are sitting in the classroom, right? As we are sitting in the classroom, according to us, blackboard, chairs, stools, right, duster, all are in the state of rest. But the person who is observing all of us, teacher even, is in the state of rest. Student sitting in the state of rest. But the person who is observing us from the outside of the earth surface, according to this person, we all are in the state of motion. Understood? So rest and motion are relative concept, important one. Now the next one is different dimensions of motion. There are different dimensions of motion, which is one dimensional motion, two dimensional motion, and three dimensional motion. Let us see these three dimensional motions in the next slide with one chart. Right. Types of motions are there. There are three types of motions: one dimensional motion, two dimensional motion, and the three dimensional motion. If the object is moving from one place to another place in a straight line path, that motion is called as what? One dimensional motion. When only one coordinate of the position is getting changed, means according to, suppose we are considering this as a x-axis, only distance is getting changed here, right? So when only one coordinate of the position of the body is changes with the time, then it is said to be moving with one dimension, right? Now examples for this, if we want, we can give motion of a car moving in a straight line, motion of the freely falling body from up to down. This is also one of the example of one dimensional motion. Now what is mean by two dimensional motion? Two dimensional motion is the motion where it is occurring in the plane in which x-axis also changing, y-axis also changing, means dimension of in a two coordinates of the body, or we can say the coordinates of the position of the body changes. X-axis is also changing position, y-axis also changing its position in a two dimensions. So therefore it is called as two dimensional motion, and the motion will be in the plane. Okay, because in a plane, x and y both axes are getting changed. Example, if you want, we can give motion of a circular car, right? Car is moving on the circular turn, that one. Motion of the billiard balls, also we can consider projectile motion, which we have thrown, a ball is thrown from one place to another place. This is also one of the example of what? Two dimensional motion. Now the third and the last one is three dimensional motion. Motion of the body in a space is called as what? Three dimensional motion, in which x axis, y axis and z axis. Three axes or three positions of the coordinates are getting changed, therefore we are calling it as a three dimensional figure, and this will area will considered as a space. Here space will be considered, right? Examples if you want we can give, which is having just like which is having length, breadth and mass, volume, right? So just like a volume, three dimensional figure. So motion of flying kite, motion of flying insect or motion of flying birds we can consider in this example. I hope do you understand. Thank you for watching. Please like, share and subscribe. Thank you.